Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Index Cards by L.M. Damasi, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We have black dots separate cells where one digit is double the other, and white dots separate cells where digits are consecutive, and not all dots of either color are given. Well, it should be not all dots are necessarily given, but these are Kropke dots. So, for example, if this were, say, a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio between them. And if this were, for example, a 6, this would have to be a 5 or 7 to make sure that these digits are consecutive. And those are examples of how Kropke dots work. We also have the grid contains a set of index cards, right? These are all index cards. If a digit D on an index card is in position P in its Sudoku box, then there must be a digit P on the same index card that is in position D in its Sudoku box. Okay, if a digit D on an index card is in position P in its Sudoku box, okay. And positions in a Sudoku box are labeled 1 to 9 in standard reading order, or typical Western reading notation. So that would mean this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8, 9. Because typical Western reading notation is from top to bottom and left to right. If a digit D on an index card is in position P in its Sudoku box, so say, so this is position 2. If there is a digit D in position 2 on its index, on the index card, I think we're sort of solving this already if we do that, but let's just try to make an example. Say this was a 6. That means the digit D, so 6 is in position 2 in its Sudoku box. Then there's also a digit P, which would be 2, in the same index card that is in position 6 in its Sudoku box. So position 6 in box 1 would be here. So this could be a 2 then. So that's how index cards work, right? This is saying there's a digit 6 in position 2 in the index box, in its Sudoku box. So there's a digit 6 that's in position 2 in its box. There must be a digit 2 in position 6 on the same index card. And that fulfills it there. So that's an example. That's basically an example of how these index cards work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Index card positions, then. This is 2, 3. So we have 1, 2, 3. And we have 4, 5, 6. So these digits must be the digits 1 through 6. Here, we also have, this is 3, position 4, 1, 2, 5, 6. This is position 3 and 6. This is 1, 2, 4, 5. So again, this is 1 through 6, which means we have a 1 through 6 sextuplet in rows 1 and 2, which means the 1 through 6 cannot be in the rest of the row. So this is 7, 8, 9. This digit cannot be 5 because 5 can never be in a 1 to 2 ratio with another digit. Because if you have 5, you get 2.5. If you double 5, you get 10. Neither of which are digits. This is, again, 1 through 6, right? This is position 3 and 6, positions 1, 2, 5, 4, and 5. Oh, wait, hold up. No, yeah, these are all the possible combinations, right? You can only have a position P. None of these can be in position 7, 8, or 9, period. So this has to be 1 through 6. It cannot ever have a 7, 8, or 9 here. Because if you did, the problem is where, if you had a digit 7, 8, or 9, that means one of these digits would have to be in position 7, 8, or 9. So that's why this can never be 7, 8, or 9 here. These possible positions are 4, 5, 6, 7, 8, and 9. So this is 4 through 9. These possible positions, and this... Okay, so this has to be a 4, 8 pair. Because of 4 through 9, the only two that are in a 1 to 2 ratio are 4 and 8. So this is 4 and 8. Which eliminates 4 and 8 in the rest of the box and the rest of the column. So this can't be 4. Therefore, either this is 2 with 1 or 3, or 5 and 6. So we have either a 4 is in position 6, or an 8 is in position 6. That means 6 has to be either in position 4 or position 8. These digits are in positions 4, 5, 7, and 8. So this is a 4, 5, 7, 8 quadruplet, which eliminates 4, 5, 7, 8 in the rest of the box. So this is 1, 2, 3, 6, 9. These are, again, 4 through 9, right? Because... why is that the case? This is position 6 and 9. Position 4, 5, 7, 8. That's the reason why. So you have 4 through 9 here. 7, 8, 9 is next to either 6, 7, 8, or 9. It's consecutive with, I should say. Okay, so 6, this is saying, if this is 4, that's 8. That means 4 is in position 6, so there must be a 6 in position 4. So this is saying 4 is in position 6, so 6 must be in position 4, so that would be 6. And then 8 is in position 9. That means there must be a 9 in position 8, so that would be 9. Or if this is 8, that's saying 8 is in position 6, so 6 must be in position 8. And this is 4 in position 9, so that means 9 is in position 4. So this is guaranteed to be 6 or 9. And one of these is 6, the other one's 9. So this cannot be 6 or 9, so this can't be 6 or 9. We still have to have 5 and 7, so this is a 5, 7 pair there. Okay. So 5 is going to be somewhere in position 2, 3, 5, or 6. That means this cell must be 2, 3, 5, or 6. Because we know a 5 is guaranteed. So the problem is... I mean, is it possible to have the same? You have to have the digits 1 through 6 once each here and then here. So because of that, there's no way you can. Well, I guess you can maybe duplicate. It's going to be hard though. I think because so every in the index card, you have every position. So that means you have every digit possible. So every digit is going to have to be here. So this is guaranteed to have a 5. We don't know about this. Um, okay. Yeah, so you have to have one of each digit in these index cards because you have one of every position, right? So each digit then must swap to a different position. Is that logic sound? Can you ever have like a 1 here and a 1 here? Or some digit that's the same here? You could maybe have like 4 and 4. So 4. So maybe with itself? No. Because if you do. Right. So say you try to have like 4 and 4 here, or 1 and 1 here. Then that would say you have 1 in the 6th position, so 6 has to be in a 1 position, but the 1's already there, which is not possible. So yeah, this does have to be the digits 1 through 6 exactly. Same with this. Same with this. Okay. Huh. So if this were 5 and 6, mhm. Um, hmm. If 5 is here, that's fine. Then this has to be 2 with 1 or 3. But if this is 2 and 3, so this can never be 2, 3. If this were 2, 3, that would say 3 has to be either in position 2 or 3. And 6 would have to be in positions 2 or 3. Right, so how does that work? Well, 2 and 3 could not be here anymore because that's 1 and 4. Therefore, you can't have 1, 2, or 2, 4, or 3, 6 here. So this can't be, this is either 1, 2, or 5, 6. So say it's 1, 2. If this is 1, 2, that would mean 3 has to be in positions 1 or 2. And then 6 would be in positions 3, 1, or 2. But this would never be in a 1 to 2 ratio with each other. So this cannot be 1 and 2. Therefore, this has to be 5 and 6. Which means, well, we know 5 can never be, sorry, 6 can never be in the 5th position because we have a 5, 6 pair already in that box. So this must be 6, which makes this 5. So that's saying 3 has to be in the 5th position in its box. So that's 3. Okay. That means we have 1, 2, and 4 remaining. 2 has to be one of these two. So 2 is either in the first position or the fourth position. If 2 is in the first position, that means 1 is in the 2 position. So this is 1. If this is 2, that's 1. This must be 4. If 2 is in the fourth position, that means 4 is here and this is 1. So either way, 1 has to be one of these two. 5 cannot be here. 1 cannot be here. 3 and 6 can't be here. And we know there's a 2 guaranteed here, so this cannot be 2 here in the same box. This 5, 6 pair eliminates 5 and 6 in the same column. Remaining digits in that column must be 1, 2, 3, 7, or 9. This can't be 3 because of the 3 in the box. 6 has to be one of these two cells. This is saying in position 3 can be 3, can be 4, or 6. But 3 cannot be in positions 4 and 6. So this is position 3 to start with. That's position P, but then 3 would have to be 4 and 6, which is not possible. So this must be 3, which eliminates 3 in the rest of the row. 6 has to be position 1 or 2, and therefore this is a 1. That eliminates 1 here, so that's 2 and 4, which means 2 is in position 1, so that means 1 is in position 2. That eliminates 1 and 3 here. This can't be 1 anymore. This can't be 2. This is 4 and 6. This can't be 4. So 1 is in position 6. So that means 6 is in position 1. So that's 6. This is 4. 4 is in position 2, which means this must be 2 and this must be 5. That eliminates 4 and 5 here. This can no longer be 6 because this must be consecutive. And 6 is not consecutive with 1, 2, or 3. This can't be 4 or 5. This can't be 6. This can't be 2 or 6. This can't be 1 or 3. This is guaranteed to be a 2 here because it's the only one consecutive with 1 or 3. That eliminates 2 in the rest of the index card. So 2 is either here. 1 and this cannot be 1 or 3 because 1 or 3 would be these cells. So this must be a 2 then, which makes this 1 or 3. So 5 has to be in 1 or 3. So it's one of these two, which means this cannot be 5 here. This is 6 can be either in 3 or 6, but it cannot be actually 3 here. So this must be a 6 in the 6 spot. That means this can't be 6. This 6 eliminates 6 here, so it's 9, which makes this a 6. 9 is in the 4th spot, so that means 4 has to be in the 9th spot. So that's 4, that's 8. We don't know what that combination is. This cannot be 6. One is either in the 1st, the 4th, or the 5th spot, so this can't be 3. 3 is in 4 or 5, that's correct. 5 is either in 1 or 3, or 1 or 3, that's correct. This can't be 6 anymore, so 6 has to be one of these two. 4 can be in the 1st, the 3rd, or the 4th spot in the box, which works. The rest of box 2 is 5, 6, 7, 8, 9. And this can't be 6, so one of these is a 6 and one of these is a 5. This can't be 9 because of 9 in the column. This can't be 1 because of the 1 in the box. Remaining digits in box 3. We have 1, 3, and 7, 8, and 9. 6 is one of these two. That 6 is here. Where is 6 in row 4 then? Cannot be here because the 6 in the box. Can't be here because the 6 in the box. It must be here. Where's 6 then in column 1? Can't be here because 6 in the box. Can't be here because 6 in the box. This index cards does not allow 6 as a placement there, so this is 6, which eliminates 6 there. 6 can be here. It's one of those two. Okay, so 6 is either going to be in 5, position 5, or position 8. So this 6 position must be 5 or 8. Okay, that seems fine. Where are 1 and 3 in column 1? Can't be here because of 1, 3 in the column, so this must have a 1 or 3 here, which means this cannot be 1 or 3 there. Remaining digits in box 1 are 2, 4, 7, 8, 9. Okay. 4 has to be one of those two cells. 1 and 3 have to be one of these 3 cells. 2 has to be one of those 3 cells. These digits are consecutive. It cannot be 7, 8 because that would eliminate 7, 8 here, and this would both be 9, which is not allowed. Cannot contain 6, cannot contain 9. So that eliminates 5, 6, 6, 7. So this is 1 through 5 here. Cannot be 4, 5 because of that cell there. So it must be either 1, 2, 2, 3, or 3, 4 here. And this can't be 2. So this can't be 1 because that would be consecutive with that. 2. Where is the 2 in column 9? It has to be one of those 3 cells. 5 is guaranteed to be one of these two. Where then is the 8 in row 4? Can't be here because of 8 in the box, and this can't be 8 because of the consecutive digits here, and it can't be on this index card, and this is already a 6. So this must be 8 here, which eliminates 8 here. The 9 in row 4 has to be one of these 3 cells. That means this is 9, which means one of these 3 is 9. 4 is either here or it's this cell. We're not sure which. Where is 3 in this index card? It has to be one of these 2 digits here. Because this is 4 or 5. Cannot be 1, 2, 3, or 6. So since it's 4 or 5, it's one of those 2, which means this can't be 3 here. So since this cannot be 3, this can never be 4, because 4 would have to be consecutive only with 3 because of the 4-5 pair of the 4-5 cell in the box. So this is 1 or 3. This can't be 2 because of the 2 in the row, so this is 7 or 9. That seems fine. 9 can be in 4, 5, 7, 8, 9. Okay, so that works. We have a guaranteed 4, 5, 7, 8 here, and 4 through 9 here. That means the rest of the row cannot contain 4, 5, 7, or 8. So we have 1, 2, 3, 6, 9, and 1, 2, 3, 6, 9. And this can't be 6 because of the 6 in the column. Well, right? Because we have guaranteed one digit from each of 4, 5, 7, and 8. And there's also one guaranteed here. That means that's the two digits, the 2, 4, 5, 7, and 8 allowed in rows 8 and 9, which is why we know these. So we have a 6 guaranteed here. Where's the other 6 then? It has to be one of these 4 cells, which means this can never be 6. This can't be 9 because of the 9 in the column. This can't be 2 because of the 2 in the column. Remaining digit then in column 4 have to be 1, 3, 5, 6, or 7. And it cannot be 6 because one of these 4 must be a 6. Okay, so we have that. Remaining digits in box 5 are 1, 2, 3, 4, 5, 7. So 1, 2, 3. Cannot be 4 here, so this is 5 or 7. Where is the 8 in row 6? It cannot be here because of 8 in the box. Can't be here because of 8 in the box. So this has to be 8 also. 7 could be any of these. Remaining digits in row 5, we have, again, 1, 2, 3, 4, 5, 7. Okay. This can't be 2 because of the 2 in the box. This can't be 3. This can't be 3 because of the 3 guaranteed in the row. One out of 7 or 8. Only 1 out of 7, 8 could be here. We have a guaranteed 1 out of 7 or 8 here. Does that tell us anything? Not particularly. What are the remaining digits? Okay, so in box 4, where is a 2? It has to be one of these 2 digits, which eliminates 2 in the rest of the column. So this cannot be 2. Remaining digits in row 5. Let's just go through these scenarios. Say this was 3 and 4. If this is 3 and 4, this must be 5. So that's saying 3 has to be in the 5th spot, so then this would be 3. That seems fine. Remaining, okay, this can't be 1 because, or 3 because of the 1 or 3 in the column. Remaining digits here have to be 2, 4, 5, 7, 8, 9. That seems fine. We have in box 5 a 2, 4, 5, 7 quadruplet, which eliminates 2, 4, 5, 7 in the rest of the box. So this can't be 2, 5, or 7. This is 1 or 3. We have a 1, 3, 1, 3 pair in column 5, which eliminates 1, 3 in the rest of the column. So if this were 1, 2, the problem is this would have to be a 6, 9 pair here. But we already have 3 digits, which require the digits 6, 7, 8, and 9. That would mean 5 cells would have to have the digits 6, 7, 8, 9, which are only 4 digits, which is impossible. So this cannot be 1, 2. It has to be 3, 4. So this is 3 and 4, which makes this 5. That 5 forces 3 to be in the 5th position, so this is 3. Therefore, this can't be 3. This can't be 5. We have a 1, 4 pair in column. We have a 1, 2, 3, 4. Actually, this 4 eliminates 4 here, so that's 1, which makes that 4. 5 eliminates 5 here, so it's 7, which makes this 5, because 7's in the 7th position, 5 has to be in the 5th position. That 3 eliminates 3 here, so it's 1. This can't be 5 or 7, so it's 2, which eliminates 2 in the rest of the column. This 5 eliminates 5 in the rest of the column, so this cannot be 5. This can't be 5, so it's 8. This can't be 5 or 8 then. There's no 8 here. Where's the 5 in box 2? It has to be here. So that's 5, which eliminates 5 and 7 here. We have a 1, 3, 6 triplet in column 4. But it's also in box 8, which eliminates 1, 3, and 6 in the rest of the box. So this cannot be 6. This becomes a 2, 9 pair. That eliminates 2 and 9 in the rest of the box and the rest of the column. So this can't be 9. This is a 4, 7 pair, which eliminates 4 and 7 in the rest of the column. So this is 9, which means this can't be 9. This is a 7, 8 pair, which eliminates 7, 8 in the rest of the column. Therefore, this is 6, which must be consecutive with 7, which makes that an 8. 9 can no longer be here. 9 can't be here. This can't be 8. This can't be 7. Remaining digit here has to be a 5. Okay. So 8 is in the 6th position. That means 6 has to be in the 8th position. So this is 6, which eliminates 6 here. These can no longer be 8. 9 is in the 4th or 7th position. So this cannot be 9. That forces this to be 7. That's saying 7 is in the 5th position, which means 5 has to be in the 7th position. So this must be a 5. This can no longer be 4 because of the 4 in the column. So this must be 9, which makes this a 4. Right? 9 is in the 4th position. 4 is in the 9th position. This 4 eliminates 4 here, so it's 7. This cannot be 7 or 8, so it's 4 or 5. This can't be 4 or 5, so it's 7 or 8. We have a 7, 8, 9 triplet in column 1, which eliminates 7, 8, 9 in the rest of the column. This can't be 7 or 8. It must be 4. That 4 eliminates 4 here, so it's 5, which makes that 4. Obviously, this can't be 4 anymore. This 9 eliminates 9 here, so it's 2, which makes that 9. This 2 and 9 eliminate 2 and 9 here. This can't be 9 either. This can't be 9, and this can't be 9. This 2 eliminates 2 here. We have a 1, 3, 1, 3 pair in row 8, which eliminates 1 and 3 in the rest of the row. So this can't be 1 or 3. It's 6. So that eliminates 6 there. Okay, we can't... What are the remaining digits in column 1? It has to be 1, 2, 3. And this can't be 2 or 3, so this must be 1. This can't be 1 or 3, so it must be 2. This can't be 1, 2, so it must be 3. That means this can't be 1, 4, 5, so that makes that 7. This 7 eliminates 7 here, so it's 9, which makes this 7. This 9 eliminates 9 here, so it's 8, which makes this 9. This 7 eliminates 7 here, so it's 2, which means this can't be 2 or 7. That's 8. This 2 eliminates 2 in the rest of the column. So we have a 1, 3 pair now, which eliminates 1 and 3 in the rest of the column. So this can't be 1 or 3. This is 9, which makes this a 2. 9 eliminates 9 here, so it's 7, which makes that 9. This 8 eliminates 8 here, so it's 7, which makes that 8. This is saying 5 is in the 4th spot, which means 4 has to be in the 5th spot. 7 is in the 8th spot, which means 8 has to be in the 7th spot, which it is. Okay. We have a 1, 3, 1, 3 pair in row 9, which eliminates 1 and 3 in the rest of the row, so that makes this a 2. This cannot be 2. This has to be 5, 8, and 9, and this cannot be 8 or 9 because of the 8 and 9 in the column. So this must be 5. That eliminate, and this 7 eliminates 7 here. This can't be 1, and this can't be 3. We have an 8, 9 pair in row 6. This can't be 9 because of the 9 in the column, so this is 8, which makes that 9. This 7 eliminates 7 here, so that's 1, which makes this 3, which makes that 7. 3 eliminates 3 here, so it's 1, which makes that 3, which makes that 1, which makes that 3, which makes that 1. And we have just 4, 3, 4, and 8 remaining in row 7. This can't be 4 or 8, so it's 3. This can't be 3 or 4, so it's 8, which makes this a 4. And that's the solution. Interesting use of this sort of... like, this is actually kind of similar to the index lines. that I've seen going around. But it's interesting because it's forced in specifically a card-like shape. So you could sort of view it similarly as an index line. Um, Obviously, there are more constraints here because of the positioning of where they are. But yeah, it reminds me of index lines, I guess I should say. Pretty cool concept. I don't know how further you can expand it, but I don't know. Maybe it could be actually pretty expandable to other puzzles. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.